This is video number 2 for section 5.4, solving exponential equations. This is really the main skill of this section. This is what we've been trying to figure out for some time. How do we solve an equation where the unknown, the x, is up here in the exponent position? How are we going to get that down on the main line? Well, the answer is we're going to use logarithms. I've given you the list of steps over here on the side. Let's follow that. Step 1 says you've got to start by putting your equation in exponential form. Exponential form, you remember, means one base, one power, and one result. That means this number 100 is in my way. It's messing it up. Well, how am I going to get rid of that 100? Well, currently the 100 is being multiplied by the rest of this thing. How do I get rid of something that's multiplied? I divide both sides by that number. So I need to divide both sides by 100, and that gives me 1.06 to the x equals, in this case, 2. 100 went in evenly to 200, so I simplified. If it hadn't gone in evenly, I would have just left it as a fraction. One common mistake that people make in this first step is trying to get rid of the 100 by multiplying it by the 1.06. That would be bad math. The 100 has an exponent of 1. The 1.06 has an exponent of x. There is no rule for multiplying two items together with different bases and different exponents. The only way to get rid of that 100 is to divide it out. Okay, now I have this statement that's in exponential form. One base, one power, one result. You might be thinking that our next step is going to be to switch this to log form, to use that switching forms property. And I could do that. It's just not very helpful. That would leave me with a log base 106, and that's undesirable. I don't want a strange logarithm. I want an easy one, one that I can work with in a more simple fashion. And so instead of doing that, the next step, as you can see in the list there, is, and this is really the key step, take the log of each side. And when I write log there, I mean log base 10, the one that we have a button for on our calculator, the one that's the easiest log to use. Taking the log of each side is similar to dividing both sides by 100, adding 5 to both sides, square rooting each side. In this case, I'm just taking the log of each side, which really just means I'm going to write log in front of the left, and I'm going to write log in front of the right. Sometimes this step bothers people because normally when you solve equations, each step gets a little simpler than the one before. It feels like we've made this worse somehow, but it was our only option. Introducing logarithms is what we had to do. I'm sure you can see why. If you look at that third step, that third step says that now I'm going to use the power rule of logs. That's the one that said, if you look at the left side, if you have the log of a base raised to a power, you can bring that power down to the front. Well, that's what we've needed to do. We needed to find some way to get that x down on the main line. Another common mistake that people make in these problems is they know that logs are going to come into play, and so right at the beginning they'll try to log both sides. Well, that's no good because this expression over here, the original expression on the left, is not just a base and a power. It has this times 100. The power rule of logs doesn't address that situation. It only addresses the situation where you've just got a single base and a single power. So you have to get rid of the 100 before you introduce the logs. All right, well, let's go ahead and use the power rule of logs. I can take this power, according to the rule, and I can move it to the front as a multiplier. And that is going to give me x times log of 1.06 equals log of 2. Log of 1.06, that's just some number, some exponent. Log of 2, that's just some other exponent. Don't worry about what they are right now. I don't want to introduce any rounding in the middle of my problem, so I'm just going to leave them as they are. Well, the final step, we're almost done. We've done the hardest part. We got that x down on the main line. All I need to do now is isolate my x. And essentially, the only reason it's not isolated now is it's being multiplied by this exponent, this logarithm. Well, I can easily fix that by simply dividing both sides by that number, log 1.06. And that gives me a final result of x equals log 2 divided by log of 1.06. This would be the exact answer. Remember, these are base 10 logs. Most of the time we're going to want a decimal approximation. Well, this is very easy to type into the calculator. These are base 10 logs. Just type it in exactly as it appears. Log of 2 divided by log of 1.06. And rounded to 4 places, we get x is around 11.8957. That would be the approximate solution. Remember, you don't want to round anything until the very end of the problem. So don't touch your calculator until this very, very last step. You could easily check your answer to this problem by simply going back up to the original equation, filling in 11.8957 for the x. You could do it right on the calculator. You could type 100 times 1.06 to the 11.8957, and you should get 200, or at least close to it. We rounded it off. It won't be exactly 200, but it'll be pretty close, and that would convince you that you have done the problem correctly. You need to make sure to practice this process over and over until it becomes automatic for you. Let's try it again in a second example. This example looks just a little bit more complicated. It is, once again, an exponential equation because the unknown, the x, is up there in the exponent position. The only way I'm ever going to get it down is to involve logarithms. But don't jump into that at the very beginning. You can't use logarithms until your equation is in exponential form. This time I have 2 algebra steps I'm going to have to do. I have this minus 8 that I'm going to need to do to both sides. That gives me 3 times 5 to the 2x plus 1 equals 13. I'm still not quite in exponential form because of the times 3. I rid myself of that by dividing both sides by 3. And now I have 5 to the 2x plus 1 equals 13 thirds. I'm just leaving this 13 thirds. It does not make a nice decimal, and I don't want to round in the middle of the problem. Now I'm in exponential form. Exponential form is 1 base raised to 1 power equals 1 result. Once you're in exponential form, that's the moment that you can log each side, meaning base 10 log. That's as simple as writing log in front of each side. Why would I introduce these logarithms? Why would I suddenly make my equation seemingly more complicated? Only for one reason. It's to take advantage of that power rule of logs, because on the left, I now have an exact match. I have the logarithm of a base raised to a power, and in that situation, I'm allowed to take that power. It's a little bit of a messy power, but I'm allowed to take it and bring it down to the front as a multiplier. Now, because it is a little bit messy, I will need to keep that in a parentheses. That entire exponent needs to be multiplied by log of the remaining base, in other words, log of 5. The right side remains the same. Now I'm trying to get x by itself. It looks like dividing by this log 5. Remember, log of 5 is just some decimal number off the calculator. Well, in order to get rid of it, let's just divide both sides by log 5. And now on the left, I just have 2x plus 1, and on the right I have this division problem of the two logs. Well, I have just a couple of simple algebra steps left. In order to get this x by itself, I need to subtract 1 from both sides. That will give me on the left side simply 2x. And on the right side, it's kind of a mess. I have that division problem of the two logs, and now take away 1. My final algebra step would be to divide both sides by 2. On the left, it's very simple. On the right, it's somewhat ugly. Now x is by itself. I get a final exact answer of the ratio of the two logs minus 1 all divided by 2. Now this can be tricky to type into the calculator. We haven't wanted to use the calculator because we don't want to round in the middle. Let me give you a couple of options of what you might do. So here's the calculator. I think the easiest way to type that thing in is to do it in pieces. So first, just type the ratio of the logs. So log 13/3 divided by log 5. These are base 10 logs, just like we wanted. And then hit enter to get a preliminary answer. Now that does create a long decimal, but the calculator will store that for you. In your next step, just type take away 1. Notice the calculator is taking your last answer and subtracting 1. That's exactly what we want. Hit enter again so that you have another preliminary answer. Now we want to take that answer and divide by 2. Our final decimal value is negative 0.0445, rounded off to 4 decimal places. The other option would be to try to type it all in at once. There's just so many more places you can go wrong. Because the calculator follows order of operations, you would have to put a parentheses around the entire numerator before dividing by 2. Let me show you what that would look like. So I've typed it in. Notice that I opened a parentheses at the front of the numerator, and then I closed a parentheses at the end of the numerator. If I hadn't done that, the calculator would not understand that I want to divide all of that stuff by 2. It's just a little complicated because you also have the multiple parentheses in place for the logs, and it's just easy to forget something. If I hit enter though, I should get the same result. Sure enough, negative 0.0445, again rounded to 4 places. Either way is fine. You just want to make sure and practice until you are getting these right every time. So we'll finish this problem by just jotting down our final answer. Our final decimal answer was x is negative 0.0445. That is the solution to the original exponential equation. This is something you can get very, very good at. You just need to practice it several times until it becomes automatic.